You used to get raided by 1,000 CIA agents at all our names.
Lynch.
Yeah.
Okay, click and close, give me just a few minutes here, and I'll let you work on this stuff. I wanna kinda wrap up one thing we didn't get to yesterday. So if we've got a function like, let's say, we're taking the limit of 3x cubed minus x over 2x cubed plus 9x squared plus 11. As x approaches plus or minus infinity. Okay, what's our rule? What's the answer?
3 over 2.
3 over 2, right? Because I have the degree of the polynomial on top is the same as the degree of the polynomial on the bottom. Okay, there's another way. Remember the demonstration we did at the end of class yesterday, right? What's the, if we're approaching positive or negative infinity, so for large values of x, what's the dominant term on the top? Only term that matters on the top. 3x cubed. What's the only term that matters on the bottom? 2x cubed. So another way to go about this, we did one approach yesterday where we factored out powers of x and took limits. We could even say this. This is equal to the limit of 3x cubed over 2x cubed as x approaches plus or minus infinity. That make sense? Okay, prove it to you. Let's look at this one on Desmos again.
Are you recording?
I am recording. Thank you for checking. So let's make the first one f of x. And that is 3x cubed minus x, all divided by 2x cubed plus 9x squared, 9x squared plus 11, okay?
Oh.
Just go back, there we go.
Yeah.
That's better. I was wanting to do, actually I can just do that, can't I? So now we'll go g of x equals, and I'm just going to do this. And I'm just going to delete those guys and these guys. Okay, so they don't look the same, do they? They don't look the same at all. Okay, until I start zooming way out. And when I zoom way out, look what you see. They both observe the same asymptotes, right? And that's all we care about, isn't it? Are the asymptotes here. Even if I make the vertical axis really tiny, I mean, yeah, there's a huge differences in here, but that's not the responsibility of the limits at infinity. Right? The limits at infinity only care about the tails of the function. They don't care about what's going on in between, right? And so we can make this statement, the limits as x approaches plus or minus infinity of both of these functions are clearly the same, and that's all we care about. And so that makes this problem easier, doesn't it? Because algebraically, what can I do now? Cancel the x cubes. My answer is 3x, right? Okay, just another approach to that. Okay, so let's carry this approach forward into this problem. This is where we left off yesterday. Okay? So this is not a rational function, right? But we can do maybe the same line of thought on this one that we had before. So what is as we approach positive infinity in this case, what's going to be the dominant term on top? The 2x. What's the dominant term on the bottom? Okay, it's the x squared inside the radical. Agreed? Okay, but that's the term as we approach positive infinity. That's the term that's going to dominate this polynomial. So does it make sense then? You tell me. I could write this as what, as long as I'm sticking to my limit at infinity, this is equal to the limit of what simpler function?
2x. Yeah, 2x.
2x over, okay, where'd you get the x?
The
Square root of x squared, okay, but the square root of x squared is not x. What is it?
Plus or minus x.
Absolute value of x, okay? Okay. So what in the world does that look like? Let's focus on that animal. Square root, or x over the absolute value of x. So let's look at that as a piecewise function for a second. Same thing. So what's that going to look like? For values of x greater than 0, what happens to the absolute value? Just the absolute value of x would just be x, wouldn't it?
Yeah.
And so I'd get x over x, which is, okay? For values of x less than 0, the absolute value of x would become, okay, but what's my rule there, right? We looked at this the other day. We looked at the example, if I've got the absolute value of a, it's equal to a when a is positive, but negative a when a is negative. That's how we turn it positive, multiply by -1, right? So then if if the piecewise function is going to render that absolute value of x as a negative x for negative values of x, negative x over x simplifies to what? -1. Now what about 0? Is that allowed? It's not allowed. How come? You can't divide by 0, right? So here, this is a case where 0, the function is not defined at 0, right? It's only defined for values greater than 0 or less than 0. So what's that look like if I graph it? A +1 and -1. What's my function look like? For values of x greater than 0, it's equal to 1. What would that look like? Okay, for values of x, what's the graph of that piecewise function look like? Values of x greater than 0, y equals 1.
Would it be like the staircase? Or just like the street?
Kind of, but it's a pretty boring staircase this time. It's only got one step on it. Right? Because for all values of x greater than 0, that's just all positives.
Yeah,
It's just a straight line.
I get that, don't I?
And then at -1, you have
Yeah. Right? So it's a pretty boring one, but it's not a very tall staircase.
just
But,
stepping onto the porch.
right, there you go.
That's fine.
Okay? So if I'm going to multiply this piecewise function by 2, well, what do I get? It's just going to raise this thing up, right? I'm just multiplying this function by 2, which extends the amplitude by 2. Everybody agree?
Yeah.
Okay? So the answer then is, as we approach positive infinity, the answer would be 2, right? And we could evaluate that. We didn't have to look at the graph, but it's important to do because we see this function quite a bit. This is I use this a lot in programming. If you want to control the sign of something, this is a great way to do it. Like if you, well, I won't bore you with that stuff, but this is something that gets used a lot in math and logic. This kind of a function. We could evaluate this directly. We know that for positive values of x, we could have just done this directly. We would have known that the absolute value of x is equal to x, and so it's pretty clearly equal to 2. Okay, what's the big trick though, right? The big trick was using our, trading this complicated limit for one that's much easier as we approach infinity, right? So we get single terms on the top and bottom that we can compare. Make sense? Okay. Does this share a single asymptote? It didn't, did it? Right. As we approach negative infinity, the answer would have been -2. Yes, sir.
Yesterday, I thought you said that infinity over infinity was
Indeterminate.
indeterminate.
Means more work.
Yeah,
Exactly.
so we have, over there, we have 2 infinity over infinity, right?
You're right.
So.
So the
Is it
more
still
work was that we we were able to reason out that this function is always becomes either 1 or -1 depending on which tail we're approaching. So we resolved the indeterminacy, and we got an answer. We got an answer of 2. Okay? Does that make sense?
Yeah.
Okay. All right. Questions? We'll let you work.
Is there an assignment for this?
There should be,
Yes.
yeah.
Or,